What's up, folks? Like we said, today we're talking all about the ex-Apple engineer who's creating the Apple Watch to help everyone get clear skin. Pretty interesting story behind this one.
We love episodes with a good story.
We always love episodes and really the engineers and creators behind awesome technology when they've got an awesome story. And that's pretty much what compelled us to talk about this one. Dr. Simiao New, who was troubled by psoriasis in his youth. I can relate. I've also been troubled by psoriasis.
This is a personal episode.
Yeah. It hits deep in my heart and on patches on my knees and elbows as well. But Dr. New has struggled with inconsistent treatment results, lack of feedback. And I can understand as an engineer, right? It's really challenging to feel like some aspects of your health are really easily quantitatively measured. Like, oh, I want to improve my blood cholesterol. Well, you can just go get another complete blood count and compare your cholesterol from the moment before and be like, oh, my cholesterol has improved.
Right.
Or if you'd be like, oh, I want to lose weight, you get on a diet routine, you work out, you lose weight, you step on the scale, bang, you can measure the product of your work. But with treating psoriasis, it's really challenging to quantitatively measure how well it's doing. Is it improving? Is the treatment effective, or are the side effects not worth it? So his goal as an engineer is to kind of create an electronic patch that treats skin blemishes like psoriasis and provides continuous feedback.
This is a goal that I think is worth saying. It kind of it was inspired by the work he was doing at Apple.
That's what I was going to say is I kind of alluded to it earlier, right? He helped create the Apple Watch.
Yeah.
He's going to create the Apple Watch for clear skin. But it's really interesting. Dr. New worked at Apple on the Apple Watch, creating electronics specifically for health monitoring and measuring to do two things, right? To one, help measure health, and then two, improve it. That seems like a theme here. He wants to make sure that you make devices that, one, measure health, and then two, improve it. He wants to create a wearable device for skin ailments that do this too, but when he was at Apple, he was working on, I think it was the temperature sensor and the ECG sensor that are inside the Apple Watch on my wrist right now. And when he was at Apple, he was developing these wearables that, again, one, help measure how health is doing, and two, help you improve it. He created the ECG sensor for Apple Watch and literally got hundreds and hundreds of thank you notes shipped to his desk from people who were thanking him for being thank you to the engineer who helped develop this ECG sensor. It helped save my life by detecting this arrhythmia or this heart attack, etc. And that really inspired him to be like, whoa, we're able to do this for some types of health ailments. And granted, these were life-saving ones, but can we do the same thing for this problem that's been plaguing me for my whole life on my skin?
Yeah.
Is there something similar we can do using similar technology? And that kind of is his so what or his why story, motivating him to make this development.
Yeah, and the beauty of the Apple Watches is that it gives you a lot of holistic snapshots. It gives you insight about your the healthiness of your sleep, et cetera, et cetera. But at the core of it, it really boils down to your heart health. And that's what it's actively measuring. And the messages that you were mentioning, it was because they were able to pick up these irregular heartbeat patterns and pick up on, I'm going to butcher saying this, atrial fibrillation, which is a silent killer that most folks cannot detect, but the Apple Watch does. So hundreds of people literally got notifications of hey, you're at risk or there's something abnormal going on, go to the doctor. And that's what ended up saving their lives. So it was really easy for him to make that connection of, oh, here's one specific condition that we were monitoring, for one muscle, which was the heart. How can we extract that same concept and now apply it to the psoriasis problem? And let's just jump right into the what's going on here, the solution. What do you think?
I think it's the perfect part, right? So Dr. New leaves Apple, goes to Rutgers University. Previous background, got his PhD from Georgia Tech in both materials engineering and in materials engineering and in electronics.
Jack of all trades.
I know, jack of all trades. And so combining these two worlds, along with the world of bacteria, the world of living biology, is able to combine advanced materials, advanced electronics, and living cells to create this awesome patch that is designed to treat psoriasis, but can also potentially help treat other skin conditions. And it's about 1 inch in diameter. It's really wafer thin. And like I said, the main aspects here is the electronic chip, the bacterial cells, and then a hydrogel starch that's made from gelatin that helps hold the bacterial cells on the electronic chip. And
it's the first of its kind. I think that's also worth saying. There's a lot of bioelectronic strips and patches and whatnot, but typically the way they work that differentiates them from this is that you have the electronics and some sort of like embedded in some sort of a flexible polymer that you're just strapping on yourself. But what you just pointed out, that little gel, which is helping distribute the bacteria cells that are in there, that's what's giving it a living component. So this is a first generation living bioelectronic patch.
Yeah, not just bioelectronic. It's living bioelectronic patch. And I thought it's pretty interesting diving into the bacteria on this. I thought, counterproductive to have bacteria living on this thing. I was so confused. How does this treat something like psoriasis? But I think it's really awesome. They targeted the specific type of bacteria called S. epidermis, which is already a part of the skin microbiome and is part of your skin's natural response to things like rashes on your skin. And it actually thrives in the oils on your skin. And one of the things that they found on trials in mice is that if they have a skin condition like psoriasis, introducing additional S. epidermis bacteria helps reduce inflammation. So it helps reduce some of the nasty effects from psoriasis, like itching, like pain, like swelling in the local area of the disease, because these bacteria actually secrete anti-inflammatory compounds when the patch is placed on the skin. So you basically got this awesome method of treating psoriasis. You've also got a flexible PCB that's kind of like the skeleton of the device holding it all together. This flexible circuit monitors the resistance of your skin, the temperature of your skin, and the humidity of the skin, which is this data is transmitted wirely to your computer, to your cell phone, and essentially between understanding the relationship between the bacteria that are on this skin emitting these anti-inflammatory compounds, as well as these different signals, again, skin resistance, skin temperature, skin humidity. They can start to measure how the effectiveness of the bacteria is at reducing the symptoms associated with psoriasis. Yeah.
And it's interesting because they started testing on rats that had psoriasis-like symptoms or conditions, and they are seeing they're able to demonstrate that this patch does have improvements to those conditions. So now their next step is to actually move forward with human testing. It's possible that folks like you will be able to access this technology in the not so distant future, which is pretty promising.
Yeah, I'm really excited about this. And one of the things that I think is awesome is we talk about this with a lot of technologies in a similar space. Once you've taken a novel approach, the best thing to do is look for, like, all right, did my thesis or did my hypothesis work for this one application I wanted to? Did this living bioelectronic device help with treating psoriasis? Yes, it did. Now, in this case, have we also created a platform that can help treat a bunch of other similar skin conditions or other conditions? Yep. In this case, they have a strong hypothesis that they think so as well. So not only have they developed something to help treat psoriasis, they understand that the same S. epidermis bacteria secreting anti-inflammatory compounds could really help with healing of really big trauma to the skin. So like think really, really serious wounds or, maybe your wound from a surgery or something like that. You can use the similar bacteria to help promote healing. They also said it can help with skin cancer after the cancerous cells have been removed, can help the localized area to heal faster. And more so than just promoting the healing using the bacteria, they said for doctors, it could be really, really interesting to get continuous feedback and real-time monitoring on how the wound is healing using this data that comes along with the living bioelectronic patch. Right. The electronic part of that, collecting a lot of data over time can help doctors understand how wounds are healing and whether it deserves extra attention or not.
And I'm wondering, like, if they find other bacterias that could be helpful for different conditions. It seems like this platform is flexible enough to adopt those new bacteria as well.
Well, yeah, and it's the touching back at Dr. New's advanced materials education. right? This hydrogel that's made from starch and gelatin is kind of what promotes the fact that these bacteria can live in this hydrogel and then also be compatible with the skin, like you're saying. I'm wondering if there's other living organisms that could be introduced to this bacterial cocktail, essentially, and promote different types of effects. Maybe you want one that's antifungal to help fight a fungal infection, or
that's a good point. Yeah,
maybe you want a different type of bacteria that helps combat other bacterial infections, or maybe you just want a higher concentration of S. epidermis to help reduce inflammation for a different type of condition.
Yeah, no, I agree. What do you say you wrap up this this little episode?
Well, I will say right before we do this, I think that one of the things I want to start doing in the podcast, we kind of get like, we've gotten called out a couple times for being like, oh, you're just tech cheerleaders. You only talk about the pros, you don't talk about the cons. So I'm going to be very purposeful, I think, moving forward to try and talk about some of the pros and some of the cons, summarizing the so what. Because I feel like we touch on the pros and the cons every single time, but just to like dangle that fruit out there for the haters a little bit, I understand. I also get frustrated if I feel like people are just tech cheerleaders. That's not what we're here to do.
It's tough when you're so excited about a topic like this. I'll say that.
We can be futurists, but we can also be measured futurists.
I hear you.
In this case, I'm gonna hang it out there for you, the haters. The pros, right? This device offers a novel approach to bioelectronics. It allows electronics to incorporate living cells, can allow patients and doctors to monitor their healing process as well using the electronic sensors. This can lead to more effective and personalized treatments. But the cons, clinical trials are needed first before this can be used on humans. It's only been tested on rats. And beyond clinical trials, FDA approval is required for this type of medical device before commercialization. This could be a really lengthy process. So, for folks with psoriasis like myself who are excited by this, maybe you got to sign up for the clinical trial to get access to it, or it could be a couple of years before we see this thing in the field if it gets approved. So again, for you haters out there, the pros and the cons laid out perfectly for you. Just want to make sure that we're not, we're not being paid by anyone to talk about this and shill it.
We do it for the love of the game.
We do it for the love of the game. In this case, we're talking about the pros and the cons of the game.
Exactly. Good man. I appreciate that.
All right. Now that I've gotten that off my chest, I'm happy to wrap up this episode, man, with a quick recap.
Let's do it.
This Apple engineer who helped create the Apple Watch wants to help everyone get clearer skin. His goal was to create an electronic patch that treats skin blemishes like psoriasis, which I have on my knee, and provide continuous feedback to patients as well to understand how their health is doing. But traditional treatments are inconsistent, they don't offer real-time monitoring, and they're not easily measurable. So he took his background from Apple, creating the Apple Watch, combined electronics with anti-inflammatory bacteria to create a tiny patch that can monitor skin conditions and heal blemishes quickly. It's like having an Apple Watch, but for skincare that both heals and tracks the condition of your skin. And that's why this tiny microchip designed by an Apple engineer is going to be the future of getting clearer skin.
You have me at Apple Watch for skincare. That's going to be the episode title.
Boom, 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 boom.
Money. All right, folks, thank you so much for listening. And as always, we'll catch you in the next one.
Peace.